Hey everyone, this is Carl and this is week 11 and we're continuing. This is chapter 14, problem number 4, and we'll just go ahead and get started. A cost of living survey for various cities in the world was published for 2010 and 2011. A regression was run on the 10 most expensive and 10 least expensive cities in the survey, comparing the 2010 and the 2011 cost of living indices for these 20 cities. The 2011 indices for the most expensive cities range from 137 to 161, and the indices for the least expensive cities range from 46 to 62. And you can kind of see that here. Uh, and again, we're just kind of learning how to just look at what a regression output. R squared right here, 99.3%. Remember from problem number 1, what is our S? Remember, we can just flip back real quick. Our S means the standard deviation of the residuals. Okay, and degree 18 degrees of freedom. And see, here's our dependent. So, as you can tell, these two variables kind of line up, and you'll see just real quick, one of the questions that you'll get on your homework is, what exactly does this look like? What does this data tell us right here in terms of, all of these, with the degrees of freedom and the 99.3? This is what it would look like. This would be your regression. And if you notice what these are the indices that are noted. So if you go back up, and notes about the most expensive cities, the indices range from 137 to 161. You can kind of tell just by eyeballing it, you're right around there, looking right here. So just right around that range, and then going back up for the least expensive, 46 to 62. And you can kind of tell right here as well, just about the same if you look on your x-axis. See? And then if you look over there. So that's a general idea of what this regression would look like. Later on, we'll learn kind of how to do this actually in Excel and create a regression curve. But in terms of the questions, it's just kind of asking, so what do you think this would look like? Based on those indices, based on the information that we have here. And one of the questions is the R squared of the regression with only the 10 most expensive cities. Now remember in our question, this obviously are both the least expensive and the most expensive cities. So the R squared of the regression that only includes the 10 most expensive cities, this cohort right here, is 0.84 compared to when it has both, it is 99.3. Why is that? Why is the R squared with regression with the 10 most and the 10 least greater? Well, a good rule, the two data in two widely separated groups can cause the R squared to be larger than otherwise. So because they're two groups and they're very different, when I say different, obviously the indices, you can just kind of tell these groups have really nothing in common in terms of overlap of the data points themselves. So that's why our R squared is a lot larger compared to only containing one of these cohorts. So we hope this helps you out, and just let us know if you have any questions. Thanks so much. Bye-bye.